mighty phantoms of the evening sky. To whom do these celestial steeds belong when you appear to us like gods on high? What brings you here to mystify?
Welcome to the Kate Valentine UFO Show. We're with you here on 1160 WVNJ. Our guest today is Mr. William Bryant Logan. He is the author of Air, the Restless Shaper of the World. So let me just say first off, I thought this would be just another boring description of the atmosphere, nitrogen, oxygen, CO2, global warming, blah, blah, blah. But no, it is a series of amazingly interesting, thought-provoking, and even inspiring essays. Very inspiring, actually. Wonderful information in this book. And it all to describe the most vital part of our planet. So thank you for your most enjoyable book, Mr. Logan. Welcome to the show.
Thank you. I'm very glad to be with you. Thanks for what you said.
It's quite okay. It's certainly well deserved. Your book was so different from what I was expecting, and it was just great. It was really, you covered, it's going to be hard to do an interview because you covered so many topics and you covered them well. But I thought it might interest you to know, and I know you're not specifically interested in UFOs, but that the more acceptable term now for UFO is UAP, or unexplained aerial phenomena. Yeah, you like that?
Yeah.
Yeah, and your book covers a multitude of aerial phenomena I was totally unaware of, and a lot of them are more mysterious than UFOs, like your spore scooper. That was cool. Could you tell our guest about the spore scooper? Sure.
Yeah, I agree with you. I think that the amazing things that are in our atmosphere and in our soils and all around this planet are quite as amazing as it would be to discover creatures from other planets, because most of them we don't know are there. For example, I mean, when I started working on this book, I knew that there were things that we breathed in the air. My mother said, you got to eat a peck of dirt before you die, so I assumed that means I was breathing it in. But it's amazing how much there is in the air of living things, in particular of fungal spores and of bacteria.
Mm-hmm.
And I wanted to sample them. Now, the bacteria are too small for me to see, but I have a great friend who was the state mycologist of New York for more than 30 years, and he helped me to invent, using a little Dirt Devil vacuum cleaner, a machine which allows us to take samples of the air, then examine them under the microscope and see what's there, and it is astonishing.
Yeah.
I mean, in high and low, in the deep in Death Valley when it was 118 degrees, in the top of the Sierra Nevada, in the middle of winter in the Catskills, every time I've taken an air sample, I've found living things in the sample, just of ordinary air.
It is amazing. It really was. And also, not only living things, but I'd just like to do a quote from your book, and that is, there is no other planet within 20 parsecs that has the like of it, and perhaps there is no other place anywhere at all that has such air. We are blessed on this planet with that. But there have been in the past many various atmospheres, and they have produced different life forms on this planet, and they all reflect on the atmosphere itself. And as you say, that all these life forms are all over this planet all the time.
Yes, we did.
Fascinating.
Yeah, that's another thing that really delighted me, was to find out the extent to which the creatures that began life on this planet, those that breathed not oxygen, because there wasn't much oxygen free, but breathed things like methane, carbon dioxide, hydrogen, even ferric iron. They used those in their respiration to make energy. You know, and we think the great student of the beginning of oxygen on this planet is a biologist by the name of Lynn Margulies, and she had coined this term, the oxygen holocaust, and her view was that the creatures that had lived before there was oxygen in the air found oxygen a poison and a pollutant, so when suddenly there was oxygen, they died. And it's true that on the surface, you know, they could no longer live on the surface of the planet, but now where we find them is, for example, in the mud, at the bottom of a bay. You will find all those creatures, and not to mention methanogens, the oldest creatures on Earth, 4 billion years ago, live in our guts and help us digest. So these creatures are still everywhere about us.
Yeah, you did that thing on Fenchel's dance, and you were saying, you know what came out of that, though? You said it was like a small finger section of mud, and all the various creatures that it had. But what I liked most of all about that was that you did the ratio and the proportions, like the size of the sample compared to the size of the creatures in it would reflect the size of the planet and the size of the creatures here. And this sort of reflects the fractal patterns that you see in nature.
Yeah, I think you're absolutely right. And the distances they travel in their life are analogous to the distances that we travel in ours, and they create this in this tiny space an entire world, and a world that, like our world, is very much more involved with different kinds of exchange. We're often taught that it's all a matter of competition and survival of the fittest, but just as often our observation is it's a matter of cooperation and of doing things together and of joining people as well as competing with them. And that's really borne out in these little fingerfuls of mud, where in fact some of the creatures can't live except on the excretions of the others.
Yeah, well, symbiosis is definitely a life form on this planet. But what I was getting at sort of was that, with UFOs, there's a lot of theories as to what they are or how they are or who's driving them, if a creature actually is. And I think most ufologists really sort of wish in their heart of hearts for a being that's sentient and technologically competent. And I think when you see the fractal patterns here on this planet, it's almost impossible not to think that there would be life elsewhere in this universe. Do you agree with that, or do you think that we are alone out here?
I don't know. I mean, it's one of those, to me, it's a complete imponderable.
Yeah.
You kind of hope that there is. And, looking at the micro worlds really does lead you to think that, it's not that hard, actually, because creatures are so various in the ways that they can breathe and survive, as we're learning from studying these pre-oxygen creatures. Who's to say that that's not fairly widespread in the universe? The problem being, however, it's very hard, even in our own solar system, to find an atmosphere that is conducive to life forms, at least as we know them, to any kind of life form that has to develop kind of hydrocarbon molecules. You have to have certain temperatures. You have to have certain. You don't have to have oxygen. But you have to have certain amounts of the requisite elements, and you have to have a kind of dependable climate situation in which they can evolve.
Well, that's true, and I think you go over the atmosphere of Mars and Venus in your book, and they're pretty interesting, and how they developed as opposed to how the Earth's atmosphere developed. That was pretty interesting.
So they probably started. The cool thing is they probably all started out the same.
Yeah. But
their fates have been very different. So I am particularly interested. I loved watching the landing of the Mars probe. Mm-hmm. But I'd be very much more interested to find out what the heck the Mars probe finds, because whether they find remains of things or whether, in fact, they may find things actually in some way alive there. That would be really interesting.
Well, it's almost, to me, like, for example, you bring up the example of the goose that flies at 37,000 feet. I mean, the winds up there and the temperature up there and the thinning of the atmosphere up there, it's amazing that anything that depends on as much energy as flight can even exist up there. So, that's what makes me think that possibly something remains on. I think Venus would be somewhat difficult, but Mars, I think they may find something there.
Yeah, I think that would be quite interesting. But yes, the variety of life on this Earth is just, and its ability, and it turns out that the goose you're talking about, the bar-headed goose, has a couple of little mutations that happened that make its hemoglobin very, very much better at onloading and offloading oxygen. So it's so much better at distributing oxygen than even as most of the bird kingdom, which is already pretty good at it. But it's amazing that just a couple of little changes made that happen, and then now we've got this goose that not occasionally, but regularly flies over the top of the Himalayas.
And yet, commercial airliners need pressurized cabins and oxygen and everything else to accomplish the same feat, not to mention tons of fuel.
Yeah, if you want to be humbled, though, consider that the average pigeon that you see on the streets of New York City can do pretty well at 20,000 feet, where we would really struggle.
Definitely you would. I think, even the people that climb mountains have to have so much accessory equipment, too. It is good. We had a guest that wrote in. He was wondering how many planets they found in the Goldilocks zone. I think they've been 34, but basically what he's referring to are planets that exist where, as you said, the temperature and the atmosphere, the air, would be conducive to finding life on those planets. And that has to be a great interest to you when they discover things like this.
Yes, it is. But, the other interesting thing that I found in looking at our weather, our life depends upon the unpredictability of our weather, depends upon, there's order, all right, but not kind of reducible, abstractable, describable order. Yeah. And there's a guy in the 50s who did a great experiment that suggested this was true, and he did it with a dishpan, and he heated the dishpan in the middle and cooled it at the edges. Okay. So in that way he was kind of imitating the difference between the heat at the equator of the Earth and the cool at the poles, the North and the South Pole, and he figured if he could watch the way the water moved when he spun that dishpan, it would kind of be an analog of the way the air moves as it's traveling through the northern and southern hemispheres. And he found that according to the different heating and cooling and according to how fast he spun the thing, he could get just regular flow around the world. He could get a regular pattern of peaks and valleys. He could get peaks and valleys that appeared, then disappeared, then appeared again, and then continued periodically to do exactly the same thing, that same appearing and disappearing trick, indefinitely. And then he found a fourth way in which nothing ever appeared to repeat. There was lots and lots of similarity of shape, similarity of waves, but never repetition. And it looks very much as though our Earth works according to that fourth way. It's likely that the weather has never repeated even once in the history of the Earth. So that's a very peculiar way to exist. I mean, it would be possible to have a planet that had everything right, but where everything was regular all the time, which might be a very difficult place to live.
Wow, that's quite an interesting thought. I hadn't thought of it. Wow. And that it can be done so simply, too. We're going to have to take a quick break. This is Kate Valentine. I'm speaking to William Bryant Logan. He is the author of Air, the Restless Shaper of the World. A very apt title, I might say, Mr. Logan. We're on 1160 WVNJ. I would like to announce that the publisher of Mr. Logan's book, the Norton Publishing, has sent along a copy of Air to be given away. So send us an email at AtlanticCoastUFOs.com. We'll put all the entries into a hat and pull out a lucky winner that will be announced next week. And don't forget to check out the Betty and Barney Hill weekend next weekend, September 14th. We'll be right back. Hi, welcome back to the Kate Valentine UFO Show on 1160 WVNJ. Speaking with us today is Mr. William Bryant Logan. He is the author of Air, the Restless Shaper of the World. Okay, they were having a little trouble with the internet, but I think we're back on now. I'll tell you, Bill, just before the break, you were talking about that infamous dishpan, or famous, I should say, dishpan experiment. I had a professor in college that said that the very best experiments are the simplest ones. You can derive the most information from them. And that's amazing. So he was able to demonstrate that the Earth's atmosphere is constantly changing and does not have a repetitive pattern.
Yeah, he suggested that because he was able to show that of the four regimes, the one that resembled our weather maps was the fourth one, which never repeated.
Yeah, and so you would say that constant change is what causes all the constant change in the living creatures here, or how we respond to that.
Have such widespread life. Yeah. I think because when things are regular, it tends to be, it may be good for one thing and bad for another, so you might have something, but I think that one of the things that makes life happen is the kind of variable, as some people say, when you hear noises, it's because of a variation in pressure. Living things happen when there's variation rather than constancy.
Yeah, well, I'll tell you, it's obviously it has produced just a huge number of responses to this weather. I think the thing that freaked me out the most, though, was your essay on spiders and how they jumped and got around, and the bolus spider and all. That was a little freaky. You know what it was, especially? It wasn't that they did it. It was the numbers of it. I mean, my goodness.
Oh, yeah. And most of the small spiders in the world travel by air. And then they will do it by putting out of their spinnerets. They will set out a 2 or 3 foot lengths of their web silk, and the web silk will basically draw them into the air when a breeze comes up. And they could go 2 feet or they could go 200 feet. And I was able to read a really interesting study by some scientists in Uganda who were being challenged and told that the spiders they were studying were far too big to fly. So they kept going out and watching, and they finally watched these comparatively large spiders put out these from their spinnerets what looked almost like sails, and then take off into the atmosphere about 90 or 100 feet, and we never saw them again. So where they ended up, who knows? But sailors find them regularly. I mean, signs of life at sea. Sailors would regularly find spiders hitting their sails in the age of sail way out in the Atlantic or Pacific Oceans.
Well, way back in the 1700s, they had the spontaneous generation theory of life. And I can understand how they thought that, because you put something out, like a piece of chicken or, I don't know, just some garbage, whatever, and within a very short period of time, there are things growing on it. And I always wondered, well, where does all this stuff come from? I mean, you have dust all over the place, you have microbes all over. And so your book actually pointed it out, that the air is just full of these living things that are looking for a place to alight and start living.
Yeah, and start chowing down. Because basically, I mean, if we didn't have fungi and bacteria, they have many functions, but one of their main functions is to take everything that is dead and dying and transform it back into elements that the rest of life can use. We would have been buried long, long ago in dead stuff if it weren't for them. So, that's where all that stuff comes. It suddenly makes the meat start to stink and bubble. It's the stuff that lands on them out of the air, chiefly. Not only, but chiefly out of the air.
Well, I guess it was the microscope that started the realization that it was not spontaneous generation, but it was due to microbes of various sorts.
Yeah, and you can imagine having been von Leeuwenhoek, one of those first people to look under a microscope and see a cell. Yeah. And go, holy moly, what are we looking at? Is this what we're all made out of? And boy, that's what everything since then has been about in biology, is look at what we're made out of and look at what lives inside. And what is cool to me as a person who loves fungi and bacteria is in collecting samples, I sometimes get pieces of a plant that have been attacked by a fungus, and so I can see the trace of the fungal hyphae. Fungi feed by putting out long kind of feelers into the cell, and you can see them penetrating cell walls and getting into the cell and sucking up the delicious inside. So,
yeah, it's sometimes it's one of those things that you just as soon not know about. But we had a question came in from Dale, who was wondering if you had a Kindle version of your book available.
I do not know. I think they are preparing an e-version, but I'm not sure that it is ready. Okay.
The other thing, too, we can't, since we're talking about the weather, we have to talk about Lorentz and the butterfly effect. That was phenomenal. That, too, that opened up a whole new branch of science mathematics, nonlinear math, chaotic math, and again, all out of a simple observation.
Yeah, or actually a mistake. What I love about it is it was a mistake.
Okay, even better. Yeah, right.
He never would have found out about it. It's almost a proof of what he proved is that he made a mistake, and as a result of his mistake, he learned that they would never make accurate weather predictions.
Right, and if you could just go over that real quickly, what he discovered through that mistake.
Yeah, what he was trying to, he had everything that he needed as a young meteorologist. He was a brilliant mathematician. He had a job at MIT. The only problem was he was replacing a guy who did a totally different kind of meteorology, and one that, in fact, Lorentz didn't like at all. So Lorentz thought he was going to discredit this guy by using equations, which is what he was interested in. Lorentz was interested in a set of equations that would mimic what the atmosphere does. Not do it perfectly, but mimic it, and compare it with the statistical method this other guy did. So he generated, using very early computers that would take, I think it took several weeks to run a 20-year run of simulated weather, both by his 12 equations and by this other guy's statistical methods. And he was pretty good at showing that the guy's statistical methods were not so good and that his equations would do much better. But at one point he wanted to repeat a certain section of his calculations. And, you know, he couldn't just push repeat on his computer because this was a very early computer. So he basically had to set up the numbers again in the computer and then go away for 20 minutes and have coffee while it ran and then pick up the printout. Now, but to make it go a little faster so he wouldn't have to wait so long, he rounded off all the numbers he was going to have recalculated to about 1/1000th. So he thought that'll be a little bit less accurate, but just about the same. Went away, came back half an hour later, sat down the two printouts next to each other, and sure enough, they looked like the first day. Second day, there was a little difference. He said, "What's going on here?" By the fifth day, there was a lot of differences between the two printouts, and 3 weeks later, you couldn't have told that they came from the same initial observations. They were totally different. So he looked and said, "Maybe I made a mistake in entering the data." He looked and he hadn't. He said, "Maybe my computer messed up," and it hadn't. So and then he said he was a wonderfully understated man, and they tell me that he was so shy that people wondered that he was even able to deliver a paper. But apparently he writes with typical Lorenz understatement. At that point, I became rather excited.
That's cute.
Because he realized that if this was true, then the smallest thing, for example, the butterfly waving its wings in Georgia, or a seagull flapping its wings over the Pacific Ocean, might cause tornadoes or completely different weather in completely different parts of the world, completely unpredictably.
And that I guess is the key word, that it is so unpredictable. Goodness. And as you said, it doesn't repeat itself, almost never.
Yeah, never. According to their idea, never once.
Wow.
And that's fascinating. I mean, but the wonderful thing is the patterns are all similar. Mm-hmm. So we kind of know what to expect. We just don't know exactly when to expect it. Which I think is, it's described as chaos in chaos theory, but I think that's from the point of, because the chaos theory people believe the world is governed by laws and numbers and systems. And if, on the other hand, you believe that there are incredible, intricate orders by which the world operates, but that they can't be abstracted into laws and systems, then I would look at it as freedom, not as chaos.
Wow, that's a very heavy philosophical argument, I would say. And may not be answerable on a UFO show. Wow, but see, your whole book is like that. You bring up some very interesting aspects of the air, which I think most of us just take for granted. One of my friends was very facetious and said, "Air? Is he in favor of it?" And I said, "Yeah, probably." But anyway, we need to just take a quick break. We'll be right back. Kate Valentine here. I'm speaking to William Bryant Logan. He is the author of Air, The Restless Shaper of the World. We're on 1160 WVNJ. Although we are going to take a short break, I'd like to announce that the publisher of Mr. Logan's book, Norton Publishing, has sent along a copy to be given away. So send us an email or send your questions or comments at AtlanticCoastUFOs.com. We'll put all the entries into a hat and pull out a lucky winner. And don't forget, Betty and Barney Hill Weekend next September 14, 15, 16. We'll be right back. Hi, welcome back to the Kate Valentine UFO Show on 1160 WVNJ. I'm speaking today with Mr. William Bryant Logan. He is the author of an extremely interesting book, Air, The Restless Shaper of the World. So over the break, we had a question that came in from Dale. He said that earlier you said that the Earth's weather is never the same. And he's wondering if it invalidated climate change research showing that the planet is warming and that more violent storms compared to the past. He was wondering if warming is to be expected, as far as you know, of course.
Well, that's interesting, and that's a very interesting question. And it's actually one I had where I was talking to some good climate scientists, and one of them had a very good analogy between weather and climate. He said, imagine you have a stream. The stream has banks and the water flows down them. The water flowing down that stream is like the weather. And if you try to predict where, say, a stick you throw into the stream is going to be as it goes down the stream, you'll never do it because it's too chaotic. But you can kind of predict where the banks are going to be, and unless some major event occurs, the banks will not shift. So what he was saying was climate scientists are looking for things that shift the banks rather than trying to trace the course of things through the water. And that made a lot of sense to me because it really is. I mean, if we look at the data, it's undeniable that the planet is warming. I mean, since 1999, we have had 10 of the 10 hottest years on record. There's a lot that's going on, and it's incontrovertibly going on. So yes, warming is occurring. What will happen on account of that warming is a very interesting question. And also, if we were to become tremendous polluters again, as we were after the Second World War, we might actually make it cool instead of warm. But still, it would be an effect on the planet that would have really incalculable to the extent of saying, yeah, we'll probably have more warming or more cooling and more or less violent storms, but also very surprising results.
Well, as you said, I mean, Lorenz proved that the chaotic theory of a butterfly flapping its wings in Brazil, causing a tornado in Oklahoma. And so, I mean, that is so difficult to predict. And when you have something like climate warming and what it would do to the entire planet, that's, I think unfortunately we're going to have to wait to find out. But they have planet warming right now going on in Mars and Jupiter, according to some of the astronomical findings. So, you might find life arising in those two planets as a result of this as well. You never know out there.
That's for sure.
I guess that's one thing you can say for absolute sure. But you also you made a great essay on the sap rising, discussing how trees would pull water from the ground and bring it back into the atmosphere. And I might quote from your book again. It is the foundation of all life's fuel, talking about carbon dioxide now. It is the foundation of all life's fuel, all its structure, and all its behavior. All the solid flesh of the living has its origin in the carbon dioxide absorbed from the air, the second gift being water. And it's true, like most living things are based on carbon, hydrogen, and oxygen. And so those two molecules would be really the basis of most life forms on this planet.
Yeah, and it's in plants. It's in the trees and the shrubs and all of the plants, as well as some of the bacteria that are able to photosynthesize. That happens. We're using energy derived from the sun to combine carbon dioxide and water vapor into sugars and starches. And those sugars and starches then either get used to generate energy, get turned into energy molecules, or they get built into larger molecules that make everything from proteins to nucleic acids to all of the structural parts of a creature.
Well, just as one amazing statistic out of the hundreds that you have in your book, the air may pull as much as 100 gallons of water through a single tree in a day. That's phenomenal. I didn't realize it was that much water that went through trees. Yeah,
it really is. And since, over 90% of the ecosystem, of the creatures that live in the world are forest creatures, so we have a huge amount of forest in this world. And it's really crucial to getting that water back up into the atmosphere. Only about, I think it's at 0.01% of the water that goes through a tree is actually used in the leaves to make photosynthesis. The rest is basically just run through the tree and back out into the air, goes up as water vapor, then may condense on a cloud nucleus, and then fall again as precipitation, as rain or snow, and then start the whole process over again. But it's amazing. I can't remember right at the moment, but I do cite it in the book. An average forest puts out some incredible amount of water per year out of the forest back into the sky.
Yeah, you just said that in the book, trillions upon trillions of streams rising every day out of the growing season up into the sky. But I guess one of the things is the Amazon rainforest, the fact that that's being destroyed pretty seriously. I think that's going to have a deleterious effect on the world as well.
Unquestionably will, and one of the things that restoring it would do would be to help us with the issues of global warming, because trees take up and sequester. They say that the word scientists like to use is sequester. Basically, make a lot of gaseous carbon, make it into solids and things that are no longer in the atmosphere. Trees take up a huge amount of carbon. Someone did a calculation of the current rainforests in the Amazon, and they're taking up like 6 billion metric tons of the excess carbon that we emit. And as a result, they're making global warming less than it might be by taking up some of the garbage we're throwing into the air. So the more we had healthy forests, I think the better off we would be in terms of preventing some of the things that may happen on account of global warming.
And you depend on air currents blowing over those areas, too, to supply them with the carbon to sort of sponge up out of the air. Sometimes when weather patterns change, that affects it dramatically as well. I mean, I think that's what caused the Sahara Desert, change in the weather patterns.
Well, it's interesting. The change in the weather patterns that caused the drought in the Sahel, it's interesting that may have to do not with global warming, but with global cooling. It was most pronounced up through the end of the Second World War and leading up to about 1970, just before the Clean Air Acts came in Europe and the United States and Japan. There were tremendous amounts of pollutants in the air at that time, and pollutants tend to scatter sunlight as it's coming in. So actually, the atmosphere particularly in Europe, cooled during the years between the end of the Second World War and about 1970 when the Clean Air Acts began. And as it did that, what happened was, paradoxically and totally unexpectedly, it meant that way down south in the Sahara, right just north, the Sahara is somewhat north of the equator, and just between the equator and the Sahara is the Sahel, a lot of which is savanna. That is, not desert, but a place that depends upon rains that come once a year. So what would happen is the equator would move northward in the summer and drop its rain a little farther north in the Sahel and then return back to where it had been before. But when the air was cooler to the north, as the equator came north, it cooled quicker and dropped its rain sooner, so the rain fell before it reached the Sahel. So the net result was, because of cooling that we induced with pollutants, the Sahel ended up with a tremendous drought. That's just a totally unexpected result.
Kate Valentine here. I'm speaking to William Bryant Logan, the author of Air, the Restless Shaper of the World on 1160 WVNJ. John wrote in with a question. He was wondering what you think about all of the recent high-magnitude earthquakes that have been happening so close together in time. Do you have any thoughts about those, or is that a little bit out of the atmospheric studies that you've been doing?
Well, to some extent it is, but I have to say that volcanoes are one of the main ways that nature affects the climate and also puts new materials out onto the surface of the Earth. So the occurrence of earthquakes, which is often associated with volcanic activity, does mean that it's possible for us to get a great deal of new material basically spewed up from the depths and providing us with new soils and also changing our climate. So there's a big volcanic eruption. We often get material that's thrown up into the stratosphere and then circles the globe, and it may actually cool the planet for as much as 2 years.
Yeah, I have to agree with you on that. But I was just wondering, all these things do shape our world. You're absolutely correct in that. What would you think about a planet like Mars? Let's say there was global warming. Let's say it was just a little bit larger in mass than it is. I mean, it's a relatively small planet. Would you also expect life in some form to have arisen there? It almost seems like it would. Like, again, going back to fractal patterns, you described the formation of the solar system, which I think is fairly well accepted, the whirling mass of gas, the creation of the sun, the inner planets being nickel and iron, the outer ones being gaseous giants. But if you had two inner planets, both nickel, iron, both approximately the same mass, do you think they might have evolved life forms? I mean, you have Venus that doesn't because it's too close to the sun, although it's close to Earth in size. But if Mars had been a little bit larger and it's somewhat more temperate than Venus, do you think there are solar systems that might have two planets that are life-bearing? I guess is a long prelude to a simple question. I'm sorry.
there's no way to know, but it could well be. I mean, it could well be that there was life on Mars, but that it just was not able to survive. One of Mars's problems is that it lacks a good, strong magnetic field. Mm. We have a good magnetic field because we have a solid surface and a molten core, and there's a kind of a coil effect that occurs that creates a magnetic field around the Earth, which means that a lot of the solar wind bounces off. Not all of it, but a lot does, which means we can kind of preserve our atmosphere intact. On Mars, that may have been the case to begin with, but it wasn't after the first billion years or so. There was no longer a molten core. And as a result, Martian, when air goes up to the Martian air goes up to the top of its atmosphere, it's easy prey for the solar wind to simply break up and carry away with it. So the Martian atmosphere is now extremely thin, but there's a good reason to expect, at least so the scientists tell me, there's good reason to expect that at the beginning it was not so, and that it was much more like Earth.
Yeah, it would seem so. I mean, they're finding patterns of rivers and so on. And as you said, like the cyanobacteria, once they created that toxic oxygen atmosphere, went deeper and deeper into the mud. I think what they're hoping to find there is that some microbial type life has gone deeper and deeper into the soil where indeed it could survive. I mean, they have the extremophiles on this planet that do survive under extreme conditions. So it would be interesting, wouldn't it, to see them if they find something there?
Yeah, it would be kind of nice. It would be great if we could create kind of an interplanetary competition. It might make us behave a little better.
I don't know.
We thought somebody else there's a B team already out there getting ready to take over if we mess up too much.
Oh, I see. Well, yeah, I think that's been brought up in several political statements. Reagan said, the one thing that would unite the Earth if there was a threat from an off-world type civilization, but I don't know about that. I guess we'd have to wait to find out. But so you really feel that the atmosphere here has shaped life on Earth, and certainly if you go back a few 100 million years, I think you would not recognize this planet. And then if you go back another few 100 million years, you again wouldn't recognize it. There's been so many extreme changes. I mean, if you went back 500 million years, you would think you were on an alien planet. And it's all, you're quite right, it all reflects the atmosphere.
Yeah, and, the atmosphere is what's, it's interesting because it really is an exchange. I mean, to some extent, the atmosphere is what allows us, for example, by distributing carbon dioxide and distributing water, allows us to form the flesh and energy-making compounds for bodies at all, of whatever kind, whether microbial or us or elephants. But it's also true that all of the breathing that occurs, not only ours, but those of all creatures, all plants, all microbes, is responsible for things like the fact that there's 20% oxygen in the atmosphere. And consequently, as that oxygen rises and hits the top of the atmosphere and is struck by ultraviolet rays, there it creates the ozone shield that prevents ultraviolet rays from destroying life that lives on the surface of the Earth rather than in the oceans or buried in some protected place. And also it limits the air. The ozone shield up there, because it is actually warmer where all those collisions are occurring than the air just below it, it makes kind of a lid on the atmosphere, so you can't have weather going up much higher than the beginning of the stratosphere. It's fascinating how these things work together.
Yeah, it really is. It's, life truly is a fragile thing, depending on so many little changes. Kate Valentine here. I'm speaking to William Bryant Logan. He is the author of Air, The Restless Shaper of the World. We're on 1160 WVNJ. We're going to have to take a short break at this time. I'd like to announce the publisher of Mr. Logan's book, Norton Publishing, has sent along a copy of Air to be given away. So send us an email, AtlanticCoastUFOs.com. We'll put all the entries into a hat and pull out a lucky winner that we'll announce next week. We'll be right back. Hi, welcome back to the Kate Valentine UFO Show on 1160 WVNJ. Speaking with us today is Mr. William Bryant Logan. He is the author of a fascinating book, Air, the Restless Shaper of the World. That's put out by Norton Publishing. I'll tell you, Bill, over the break we had two interesting questions, and one was that it does seem that climate change is occurring, and they were wondering just how much of it is caused by humanity and how much of it is going to happen anyway.
Well, that's quite an open question, but, because certainly the planet has warmed and cooled on its own without any help from us a number of times in the past. It seems like this time it pretty incontrovertibly does have to do with the things we're putting into it, particularly greenhouse gases like carbon dioxide, which, there's 30% more carbon dioxide in the air now than there was in 1850. That's a pretty substantial change. And we're also now doing a great deal more of methane, which is also a very good gas at holding heat in. And it's naturally occurring, right? Cows put it out, but we use huge feedlots. Liquid manure, which is now required to be used instead of solid manure in some places, also puts out methane. A lot of our resource extraction, oil wells, refineries, and of course hydraulic fracturing all put out methane gas. So stuff we've done is virtually certainly making these changes happen. Again, as I say, the main question is what are the results going to be? And several scientists I talked to said, what we're surprised by is that there hasn't been more effect than there has been yet. They think, the climate should have changed more than it has, given what we've been doing.
Yeah. Well, along those lines, we had another question that came in and said that since so many animals have adopted, if the atmosphere does change and we do get global warming, let's say to an extreme effect, do you think there would be some adaptations at that point with other life forms coming along?
Well, there sure will be, but the question is whether we'll be one of the life forms that adapts or not.
Yeah, I don't think so.
Yeah, we might not, and that's it's very interesting. I talked to a wonderful meteorologist, a weather scientist named Kerry Emanuel up at MIT, and he was talking about global warming and what might happen and how we might lose a third of all species. And I said, but come on, Dr. Emanuel, is this surely going to happen? And he had the most wonderful analogy. He said, no, it's not surely going to happen. But listen, it's like this, he said. If you don't buy fire insurance on your house because you think your house is going to burn down. You buy it in case your house might. And there's a reasonable probability that your house might burn down. He says, it's similar with climate change. We can't tell you exactly what will happen, but we're relatively sure that something not so good will happen, and we think it's worth buying that insurance to make sure that it doesn't. And I thought that was a pretty good way to put it. It wasn't at all hysterical, and it was kind of like just, here's what we need to do in order to make sure that these possible worst consequences do not occur.
Well, and some things, of course, are unpredictable. You had another wonderful chapter in your book about the catastrophe that occurred when something crashed into the Earth, and that something created the moon, and all the effects of the lunar effects. That was just phenomenal. I loved that chapter. That was great.
What a piece of luck. I mean, at the time, it probably seemed like the worst luck that had ever occurred to any protoplanet in any solar system.
Right.
And all of a sudden, you find that you've got this big counterweight that basically keeps you spinning in a very predictable way. Always differing, but very predictable. Whereas Mars, not having such a big a moon, really wobbles all over the map, much more so than the Earth does. So we by this catastrophe, got something rather useful to life.
Well, when you think of it, you were talking about the oxygen and creating ozone in the upper layer. There's another thing, too, is water is the only molecule that is lighter when it's in the solid phase as opposed to the liquid, so ice floats. And then you have the moon that does pretty much predict a lot of occurrences and cause irregularity on this planet. Now, those three things together are fairly unlikely to occur. So when you have people saying that it's almost impossible to believe that life occurred at all on this planet, I can understand what they mean. It's such an unlikely scenario of events that make it possible for life to exist here.
Yeah, no, it's very interesting, and it really does, it raises that chaos and freedom question again, because it seems like it's in whether you call it chaos or freedom, it's in this place of unpredictability that you can get the things that are needed in order to have living beings.
Yeah, and that's what they're referring to as the Goldilocks zone too, and they look for exoplanets. And I find it interesting, like when I was first starting in grade school, the knowledge at that time was that there were no planets outside of our solar system, which seemed very unlikely to me even as a child. And now we have so many exoplanets, which is why I think you're going to find at least one of them will have some sort of a life form on it.
May very well, or maybe life. I mean, life is such a strange experiment. I mean,
yeah.
If you looked at it from outside, you'd think, "Hey, what for? We've got all these beautiful planets doing all their thing. What do we need all this messy stuff for?" On the other hand, for those of us who are alive, it's kind of the whole ball of wax. It's the whole thing.
Well, yeah, that's a great way of looking at it. I hadn't thought of it. The planet's thinking, no, these things just mess us up.
We're pretty regular. We have our ups and downs. We explode now and again, but hey.
Yeah. Life's been good. Earl wrote in, and he was wondering if you have any comments on chemtrails and their effect on our atmosphere. I don't know if you're aware of the research that's been going on with chemtrails.
No, several people have brought this up, and I'm not in detail aware of it. The only thing that, in terms of what will happen in the air from it, that I know of is that it probably contains aerosols that may create some cooling underneath. And of course, if it's polluting material and it becomes the most rain that falls, not all, but most rain and snow that fall, it's not pure water falling. It's water in solution with an aerosol, with some liquid or solid particle. So if those trails have any pollutants in them and those combine with water and then fall to Earth, they might have effects on human health. But that's all I'm aware of.
Yeah, well, Michael Murphy has done, he's been on the show too. He's been doing a lot of research on it, but it gets into government conspiracies and so on. And, I don't think it's really been shown to be accurate at this point. They're getting very close to it, but, I think it's still up in the theoretical range. But it's some pretty, if it's true, it's some pretty nasty stuff.
There have been suggestions from more or less legitimate scientists, not necessarily great suggestions, but suggestions that one way to stop global warming would be to put lots more aerosols into the air, because as I said before, aerosols, generally speaking, cause cooling. Mm-hmm. On the other hand, how the heck are we going to do that? We certainly don't want to go back to polluting like we did in the 1950s and 60s. Right. And if we don't do that, what aerosols are we going to put there, and what unexpected effects are they going to have?
Yeah. Those unintended consequences are really a son of a gun of a thing. That's for sure. Well, now, you've written a book on air. You've written a book on dirt. I think you wrote a book, if I'm not mistaken, on oaks. Mm-hmm. And these are some pretty basic things. What would your next book be? Now that you've covered...
I'm not sure at this point.
I think the only other thing that you could study would be water. You'll have to do that.
That's a real tough one.
Well, there's a lot of it here.
I may do some variety of it.
Okay. Well, unfortunately, we've already come to the end of this hour. Thank you so much for being here. Your book was so full of unexpected and surprising effects about our atmosphere. Thank you for writing it. It was really great.
Oh, thank you, and thanks for talking with me. I've enjoyed it.
Okay, same here. Thanks again. Okay, for you, those of you out there who would like to enter to win a copy of this great book, Air, the Restless Shaper of the World, just sign up now at AtlanticCoastUFOs.com. We're going to have a drawing in the middle of the week, and we'll announce the winner on next week's show. So please don't forget also to go to our Facebook page or website for information on next week's show at the Betty and Barney Hill Memorial Weekend in New Hampshire. Thanks, as always, to both Bill and Dave for their unwavering support and help. Of course, thanks to our sponsors. Mostly, thank you for listening. Next Friday at 1, we're going to be broadcasting live, as I said, from New Hampshire with Stanton Freeman and Kathleen Martin. They are the co-authors of Capture, the Betty and Barney Hill Experience, and that will also include a tour through the White Mountains of New Hampshire, recreating the hills experience. So it sounds like a lot of fun. Have a great weekend, but don't forget, this is Kate Valentine reminding you to keep your eye on the sky and maybe the weather in the air, too. Bye-bye.
If you missed part of today's program or you'd like to hear it again, be sure to subscribe to the Kate Valentine UFO Show podcast. Go to Kate's website, AtlanticCoastUFOs.com, and sign up by entering your email address on the homepage. Every week the show will be delivered right to you, so you'll never miss another intriguing, thought-provoking interview with the top names in the UFO field. Sign up today for the Kate Valentine UFO Show podcast at AtlanticCoastUFOs.com.
Has the like of it, and perhaps there is no other place anywhere at all that has such air. We are blessed on this planet with that. But there have been in the past many various atmospheres, and they have produced different life forms on this planet, and they all reflect on the atmosphere itself. And as you say, that all these life forms are all over this planet all the time.
Yes, we just
fascinating.
Yeah, that's another thing that really delighted me was to find out the extent to which the creatures that began life on this planet, those that breathed not oxygen because there wasn't much oxygen free, but breathed things like methane, carbon dioxide, hydrogen, even ferric iron. They used those in their respiration to make energy. You know, and we think the great student of the beginning of oxygen on this planet is a biologist by the name of Lynn Margulies, and she had coined this term, the oxygen holocaust, and her view was that the creatures that had lived before there was oxygen in the air found oxygen a poison and a pollutant, so when suddenly there was oxygen, they died. And it's true that on the surface, you know, they could no longer live on the surface of the planet, but now where we find them is, for example, in the mud, at the bottom of a bay. You will find all those creatures, and not to mention methanogens, the oldest creatures, 4 billion years ago, live in our guts and help us digest. So these creatures are still everywhere about us.
Yeah, you did that thing on Fenchel's dance, and you were saying, you know what came out of that, though? You said it.
Mighty phantoms of the evening sky, to whom do these celestial steeds belong, when you appear to us like gods on high, which brings you here to mystify.
Welcome to the Kate Valentine UFO Show. We're with you here on 1160 WVNJ. Our guest today is Mr. William Logan. He is the author of Air, the Restless Shaper of the World. So let me just say first off, I thought this would be just another boring description of the atmosphere, nitrogen, oxygen, CO2, global warming, blah, blah, blah. But no, it is a series of amazingly interesting, thought-provoking, and even inspiring essays. Very inspiring, actually. Wonderful information in this book. And it all to describe the most vital part of our planet. So thank you for your most enjoyable book, Mr. Logan. Welcome to the show.
Thank you. I'm very glad to be with you. Thanks for what you said.
That's quite okay. It's certainly well deserved. Your book was so different from what I was expecting, and it was just great. It was really you covered. It's going to be hard to do an interview because you covered so many topics and you covered them well. But I thought it might interest you to know, and I know you're not specifically interested in UFOs, but that the more acceptable term now for UFO is UAP, or unexplained aerial phenomena. Yeah, you like that?
Yeah.
Yeah, and your book covers a multitude of aerial phenomena I was totally unaware of, and a lot of them are more mysterious than UFOs, like your spore scooper. That was cool. Could you tell our guest about the spore scooper?
Sure. Yeah, I agree with you. I think that the amazing things that are in our atmosphere and in our soils and all around this planet are quite as amazing as it would be to discover creatures from other planets, because most of them we don't know are there. For example, I mean, when I started working on this book, I knew that there were things that we breathed in the air. My mother said you got to eat a peck of dirt before you die, so I assumed that means I was breathing it in. But it's amazing how much there is in the air of living things, in particular of fungal spores and of bacteria.
Mm-hmm.
And I wanted to sample them. Now, the bacteria are too small for me to see, but I have a great friend who was the state mycologist of New York for more than 30 years, and he helped me to invent, using a little Dirt Devil vacuum cleaner, a machine which allows us to take samples of the air, then examine them under the microscope and see what's there. And it is astonishing.
Yeah.
I mean, in high and low, in the deep in Death Valley when it was 118 degrees, in the top of the Sierra Nevada, in the middle of winter in the Catskills, every time I've taken an air sample, I found living things in the sample, just of ordinary air.
It is amazing. It really was. And also, not only living things, but I'd just like to do a quote from your book, and that is, there is no other planet within 20 parsecs that was like a small finger section of mud, and all the various creatures that it had. But what I liked most of all about that was that you did the ratio and the proportions, like the size of the sample compared to the size of the creatures in it would reflect the size of the planet and the size of the creatures here. And this sort of reflects the fractal patterns that you see in nature.
Yeah, I think you're absolutely right. And, you know, the distances they travel in their life are analogous to the distances that we travel in ours, and they create this, in this tiny space, an entire world, and a world that, like our world, is very much more involved with different kinds of exchange. You know, we're often taught that it's all a matter of competition and survival of the fittest, but just as often our observation is it's a matter of cooperation and of doing things together and of joining people as well as competing with them. And that's really borne out in these little fingerfuls of mud, where, in fact, some of the creatures can't live except on the excretions of the others.
Yeah, well, symbiosis is definitely a life form on this planet. But what I was getting at sort of was that, you know, with UFOs, there's a lot of theories as to what they are or how they are or who's driving them, if a creature actually is. And I think most ufologists really sort of wish in their heart of hearts for a being that's sentient and technologically competent. And I think when you see the fractal patterns here on this planet, it's almost impossible not to think that there would be life elsewhere in this universe. Do you agree with that, or do you think that we are alone out here?
I don't know. I mean, it's one of those, to me, it's a complete imponderable.
Yeah.
You kind of hope that there is. And, you know, looking at the micro worlds really does lead you to think that, you know, it's not that hard, actually, because creatures are so various in the ways that they can breathe and survive, as we're learning from studying these pre-oxygen creatures. Who's to say that that's not fairly widespread in the universe? The problem being, however, you know, it's very hard, even in our own solar system, to find an atmosphere that is conducive to life forms, at least as we know them, to any kind of life form that has to develop kind of hydrocarbon molecules. You have to have certain temperatures, you have to have certain, you don't have to have oxygen, but you have to have certain amounts of the requisite elements, and you have to have a kind of dependable climate situation in which they can evolve.
Well, that's true, and I think you go over the atmosphere of Mars and Venus in your book, and they're pretty interesting, and how they developed as opposed to how the Earth's atmosphere developed. That was pretty interesting.
So they probably started. The cool thing is they probably all started out the same.
Yeah. But
their fates have been very different. So I am particularly interested. I loved watching the landing of the Mars probe. Mm-hmm. But I'd be very much more interested to find out what the heck the Mars probe